How to use Flex in PractiCAD. There's a variety of different ways to utilize the Flex inside the system. In the following tutorials, we're going to go over all the different options you have for Flex one at a time. The first part in working with Flex is learning how to attach Flex between two objects manually. In this tutorial, we're going to snap Flex between the end of the squared around and the grill neck we have here. We're going to go into our architectural bin, and we've already grabbed and placed a Flex icon in that bin. If you do not have your Flex there, you must go into your library icon and then go to the architectural section and pull it out. And there's separate tutorials on making bins for architectural items. Here what we're going to do is we're going to go in, we're going to grab the Flex and click once, and then PractiCAD is going to ask us at the command line to start Flex position. Now, regardless of what size diameter I have currently on my crosshairs, the second I snap to the first point, it is going to resize that Flex to fit. So I do not need to worry about a Flex of a specific size. Once we attach to the first point, PractiCAD is going to open up a little Flex collar window. There's only two options here: to insert a spin collar and keep it checked, or to keep it unchecked. When you're attaching Flex to the end of existing duct, as in this scenario, we keep it unchecked. Soon in other tutorials we'll explain what to do when it's checked. If we do have it unchecked, all we need to do is snap to the end and then press OK. There's nothing more. When you press OK, the Flex collar window will close. Now you can see the Flex is being stretched to my crosshairs. All I need to do is grab onto a grill and snap to the end point, which would be at the center of the grill. It's important to make sure that you have your object snaps on. Obviously, you can see in the bottom we've got object snaps turned on. If you don't, you're not going to be able to snap to the grill. If you've got them turned on, you can click once. PractiCAD is going to stretch out the Flex, and you've now successfully placed Flex between two entities. The next thing we're going to show in the Flex tutorials is how to use the Insert Spin Collar function. What we're going to do is delete the Flex and the tap here. And what we've got is just a piece of rectangular duct and a grill. If we would like, we can come into the architectural bin, we can grab our Flex, then we can come over and snap to the grill neck first. If we snap to the endpoint to the grill neck first, and then bring the Flex over to the in connection of the duct, when we click, PractiCAD will open up the Flex collar window. And here we can say that we obviously don't want the Flex on the in connection. We want to insert a spin collar. And we could choose to insert spin collar and say location on the in or out. In is the in joint. And then we can choose the spin collar we'd like to use. And here we have a catalog that's already preset. And there are separate tutorials that teach you how to build catalogs of spin collars. Here we're going to pick a 12-inch spin. Now it's asking for the inset outset parameters. This 12 inches means that we're going to put the spin's center 12 inches from the in joint. And then we've got the offset, which is actually going to control the spin's elevation up and down across the side of the fitting. So right here what we're going to do is state we want it to be at, let's say, 9, because we have an 18-inch depth fitting. We then have the orientation parameters. Just like in tap parameters, we have near, top, bottom, and far. Near always means the right side of the fitting if the airflow is coming in the in joint. Far would mean the opposite. Far is usually the left side of the fitting. So if airflow is coming in the direction you see my cursor, the right side would be near, the left side would be far. And of course, top and bottom is top and bottom. Here in this tutorial, we want to put it on the right side, so we're going to say utilize the near. Now once you press OK, PractiCAD's automatically going to place a spin collar there for us and hook the Flex up to it. And now we've successfully attached Flex and had PractiCAD insert a spin collar for us. The last way to route Flex is to use an automatic for AutoFlex to route between two points. There are separate tutorials on the AutoFlex section, but basically as a quick tip, what we can do is highlight between the end of a specific fitting and the grill, and come over to our automatic bin and just click the end of duct Flex no max automatic. If we click on that, it'll just route Flex between the points. It'll also do multiple taps with multiple grills at the same time. So this is actually the preferred method and the quickest way of attaching Flex between two points. The next thing we're going to demonstrate is explain the different parameters that we offer with Flex and how we can edit Flex after it's placed on the drawing. What we've got here is Flex placed between a conical and a grill. We're going to click on the Flex parameters and we're going to take a look in the AutoCAD property box. Here we're going to focus on the geometry parameters. There are 4 main parameters. These are the same parameters you see when you go to grab a new piece of Flex and you come into the item box. When you're inside the item box, you're going to notice that you've got the diameter, the step, the length, and the bend radius. And the same 4 parameters are going to appear in the AutoCAD property box. To explain what each of these do, the diameter is obviously going to control the diameter of the flex. That can be edited at any time on the fly, and most of the time the diameter is going to be automatically picked for you based on whatever you snap to. If you take a piece of flex and snap it to a squared around that's got 18 inches diameter out, the flex is going to adjust itself to be 18 inches. Step has everything to do with the appearance of flex. Currently, if we zoom into the flex, you can see that there's a specific amount of rings that the flex offers. And the number of rings between 2 points, or the spacing between them, can be controlled by the step. The lower the number is, the smaller the rings are, and therefore the more of them you will see. You'll notice that currently we have flex in the 3D wireframe visual style. If we are in that style and we adjust the step and lower the number from 3 to 1, what it'll do is it'll put more rings. And there you can see it's going to actually change the appearance of flex. So we can actually adjust the flex by controlling the step parameters. We can click and raise the number to have less rings, or we can lower this back to a standard number like 3. It's going to have more rings. So we can adjust it to any value we'd like. The next parameter that can be adjusted is the bend radius. Currently you can see the bend radius is set at 15. However, we can raise or lower this number. In this tutorial we're going to change it to 25, and that's going to increase the amount that the flex is bending between 2 points. The lower the bend radius, the straighter it's going to be. For example, if bend radius was just 4, you can see that now we're going almost directly from the conical to the grill. If we raise the bend radius, we're actually going to start curving more down towards the grill. So you can adjust the bend radius. The length is always calculated for us automatically. The Flex in the software will edit, and we're going to go over separate tutorials on duct line editing with Flex. But essentially what we have here is the length of the flex, and this number does not change. Whatever we stretch flex between 2 points, it's going to read this number. This number cannot be adjusted from the property box. You cannot change the length of flex here. Also, if you have any trouble changing any parameter in the AutoCAD property box, it would be a symbol that you are using flex that must be a catalog entity. Catalog entities, or if you take flex and catalog it, you are unable to change these parameters. This right here happens to be the standard PractiCAD flex. It therefore can be changed at any time on the fly. That'll conclude going over the parameters of flex and editing the flex.